we will see what is meant by polarization in dielectrics. So it is very important. So although the charges in a dielectric are not able to move about freely, like in dielectric, as we all know, it is like an insulator. The charges cannot move freely. So they are bound by finite forces, and we may certainly expect a displacement when an external force is applied. That means only when external force is applied only you can break down their forces which they are bounded by, then they will be able to move freely. So a dipole results from the displacement of the charges, and the dielectric is said to be polarized. Okay, in that condition, when external force is applied, you can say that particular dielectric is polarized, and we are going to get some dipole because of the displacement of the charges. Okay, in the polarized state, that means after getting polarized a dielectric, the electron cloud is distorted by the applied electric field E bar. Yes, of course. That distorted charge distribution is equivalent to the original charge distribution plus a dipole whose moment is p bar equals to qd bar. Like we are introducing some term which is known as moment, dipole moment p bar, which is equals to qd bar. Okay, here d bar is the distance vector from minus q to plus q of the particular dipole. Okay, so here I have mentioned the original charge distribution which is in a circular got what distorted like this, which is not in a circular area. So this we can represent it by the original distribution plus some dipole moment with the two charges separated by distance d bar. I have represented there minus q2 plus q, distance is d bar. Okay, so if there are, let us say, n number of dipoles in a volume delta v of the dielectric, okay, then the total dipole moment will be due to applied electric field E bar is sigma k equals to 1 to capital N qk into dk bar. This is of course for n number of dipoles you need to add all the dipole moments. As a measure of the intensity of polarization, we are defining one more time known as polarization. Okay, this is very important. They will confuse you in between these two, polarization and dipole moment. So this is also denoted by p bar, and the units are coulombs per meter square. This is very important. So it is nothing but dipole moment per volume of dielectric. So we will see this mathematical expression now. Is per unit volume, we need to divide that dipole moment with volume, that is change in volume. Okay, so the finally polarization is given by limit delta v tends to 0, sigma k equals to 1 to n qk dk, which is nothing but the net dipole moment, and divided by delta v. This is polarization. So finally polarization is equals to dipole moment divided by change in volume, and limit change in volume tends to 0. So you need to get a clarity between dipole moment and polarization. That is important, right?